Welcome to Catalyst Medway, where we ignite understanding and make learning easier. In our today's class, we'll be looking at correlation under statistics. Correlation is just a statistical method that will allow us to know the nature of the relationship that occurs between given variables. Either the relationship is strong, or a perfect positive relationship, or the relationship is weak, or a perfect negative relationship. Now, I don't know what the correlation is. Correlation only tell us the nature of the relationship. It does not tell us, or it does not talk about the causes of the relation as well as the effect of the relation. It only measures the association, and the nature of the relationship can be determined by using what we call correlation coefficients. Now, there are different types of correlation depending on the direction. Depending on the direction, there are different types of correlation, or the major ones are there is positive correlation, there is negative correlation, and zero correlation. So, based on the direction, we say there is positive correlation, the negative correlation, and the zero correlation. The positive correlation is a type of correlation in which if one value is increasing, the other one as well will be increasing. While the negative correlation is one in the sense that if one value is decreasing, the other one will be increasing. Zero correlation is telling you that there is no any relationship between the given variables. Now, how do we know the nature of the relationship between the variables? We can calculate it using what they call correlation coefficients. Correlation coefficient. It is the numerical or value that will tell us the nature of the relationship that happens between the given variable. And the majorly or the commonly the most used correlation coefficients are the Pearson's and the Spearman correlation coefficients. So the most commonly used correlation coefficients are the Pearson's correlation coefficient and the Spearman's correlation coefficient. Now, what is the formula for the Pearson's and Spearman correlation coefficients? For the Pearson, the formula is our correlation coefficient, which is R, is equals to the norm n multiplied by summation of xy minus summation of x multiplied by summation of y divided by root of n summation of x square minus summation of 1x square multiplied by n summation of y square minus summation of y all square. This is the formula for the Pearson's correlation coefficient. Our n here is the number of observation, where x and y stand for our variables. For the Spearman, the formula is our RS, that is the Spearman correlation coefficient, will be equal to 1 minus 6 summation of d square divided by n into n square minus 1. So in this case, our d is difference between two rasts, whereby our n is the number of observation. Now let's solve example so that we will know how to use the Pearson's and the Spearman to calculate the coefficient of correlation. So example 1 states that a teacher wants to examine the relationship between hours of study, that is X, and exam scores, Y, of students. The following data were collected. So this is the data collected. We're having 5 students. This is the hour of their study, and this is their exam score. The question said, state the correlation between X and Y. B part, calculate the Pearson's correlation coefficient. The C part, interpret the value of correlation coefficient obtained. The D part, state one limitation of correlation analysis. Now to the first part says that state the correlation between X and Y. Now based on the direction, we can know the relationship, we can know the correlation that involved between these given values. We say that based on direction, there are positive correlation and there are negative and zero correlation. The positive correlation is the one in which if the value of one is increasing, the value of the other as well will be increasing. Whereby if the value of the one is increasing and the other one is decreasing, that is negative correlation. And if there is no relationship between them, that is zero correlation. Now from this given value, we can see that as our X is increasing, our Y as well is decreasing. So the correlation between X and Y here is positive correlation because our X is increasing, our Y as well is increasing. To the part B, calculate the Pearson correlation coefficient. We say the formula for the Pearson, our correlation coefficient equals to N summation of X, Y minus summation of X multiplied by summation of Y, all divided by the roots of N summation of X squared minus summation of X all square multiplied by N summation of Y square minus summation of all Y square. Everything here in the roots. So the data we need here now is that we need our N, number of observation. We need the summation of X and Y. We need the summation of X and the summation of Y. We need summation of X square, summation of X all square, summation of Y square, and summation of all Y square. So from this table, we'll continue from this table. So the first thing that we're going to look at here now is we'll look for our X, Y. So here, our XY will multiply the value of X with Y. So from here, 2 times 50, press the calculator, it will give us 100. 4 times 55 will give us 220. 3 times 65 will give us 390. 8 times 70 will give us 560. 10 times 80 will give us 800. Then we still need X square as well. So our X square will just be the square root of the square of all the values of X. So we'll be having 2 square will give us 4. 4 square will give us 16. 6 square will give us 36. 8 square will give us 64. And 10 square will give us 100. We still need the summation of Y. We need Y square. So in this case, you do square all the Y. 550 square will give us 2,500. 55 square will give us 25. 65 square will give us 4,225. 4,225. 70 square will give us 4,900. 4,900. 80 square will give us 6,400. So now we need all their summations. We need the summation of X, the summation of Y, summation of XY, X squared, and Y squared. So in this case now, what our N is the total number of observations. And the total number of observations here is the number of observations 1, 2, 3, 4, 5. Our N in this case is 5. Our summation of X is, you add all the X together. Summation of X give us what? 30. We also need summation of y. Summation of y, add all the y together, it will give us 320. We need summation of x and y. Add all the x and y together, we will get 2070. Then we need summation of x square. Summation of x square gives us 220. Summation of y square will give us 21050. So we also need the summation of x all square and y all square. Our x all square, summation of x all square. Our summation of x is 30. That will just be 30 square and it will give us 900. We also need summation of y all square. Summation of y all square, that will be summation of y, which is 320 square, which will give us 102400. So these are the data that we need. We'll just substitute them in the formula, Pearson's coefficient of correlation formula. So we'll continue by our R here will now be equal to, we say our N is 5. That is 5 multiplied by the summation of our xy, which is 2070, then minus the summation of x, that is 30 multiplied by the summation of y, which is 320, all divided by the root of our n is 5 multiplied by our summation of x squared is 220 minus the summation of all x squared, which is 900. Then multiply by our n, which is 5, multiplied by summation of y squared, that is 21,050, minus the summation of y all squared, which is 102,400. So our R will now be 5 times 2017. 350 minus 30 times 320. 9600. All divided by the root of 5 times 220 minus 900. 200. Then multiply by 5 times 21,050 minus 102,400. 2850. So our R will now be equals to 10,350 minus 9,600. 750 divided by all the root of 200 times 2,850.
570.
000. Okay. So our R will now be equals to 750 divided by the root of 570,000 is
754.
754.98. So our R in this case will now be 750 divided by 794.98. 0.99. So this is Pearson's coefficient of correlation of this given data is 0.99. This is part B of the question. We've calculated the Pearson's correlation coefficient. The next question states that interpret the value of correlation coefficient obtained. In this case, we just interpret it since it is the 0.99, it's telling us that the relation is strongly positive. State one limitation of correlation analysis. The limitation of correlation analysis is that it only shows us or it only measures the association. It does not tell us the causes of the relationship or the effect of the relationship. So you can use anyone there as the limitation of correlation analysis. One example states that the following table shows the ranks obtained by 8 students in maths and statistics. Calculate the Spearman's rank correlation coefficient and interpret the results. This is the rank table that we are given: ranks in math and rank in statistic. So now they say we should calculate the Spearman's rank correlation. And the formula for the Spearman's rank correlation is RS, that is our Spearman rank correlation, is equals to 1 minus 6 summation of D square divided by N into N square minus 1. So I'm saying that our D is the difference between the two ranks, and it can be calculated by either you can do either R1 minus R2, or you can also do R2 minus R1. If you're having negative answer, since you'll be squaring them in the formula, you'll still be having positive answer. Anyone you do, you'll still be having the same answer. So our D in this case, we'll be looking for D. Our D, which is R1 minus R2. So our R1 minus R2 will now be 1 minus 2 will give us minus 1. 2 minus 1 will give us 1. 3 minus 4 will give us minus 1. 4 minus 3 will give us 1. 5 minus 6 will give us minus 1. 6 minus 5 will give us 1. 7 minus 8 will give us minus 1. And 8 minus 7 will give us 1. This is our T, and we need D squared. So now we are having another theorem for D squared. 1 square will give us 1, 1, 1, 1, 1, and 1. So we need the solution of our D square. The solution of our D square, solution of D square will now be equals to 8. And our N, which is number of observation, is 8. So substituting this in our formula, our Spearman rank correlation will now be 1 minus 6 times summation of D square is 8 divided by our N is 8 into 8 square minus 1. So which now be equals to 1 minus 6 times 8 will give us 48 divided by 8 into 8 square will give us 64 minus 1, which now be equals to our 1 minus 48 divided by 8 into 63. Then our 1 minus 48 divided by 8 times 63.
504.
504. Which now be 1 minus 48 divided by 504. 0.095. Which now be equals to 1 minus 0.095.
0.905.
0.905. So this is our Spearman rank correlation coefficient, 0.905. And they say interpret the result. Since we also have a 0.9 something or 0.905, the relationship will be strong or perfect positive relationship. So this is how you can use the Spearman as well as the Pearson's coefficient to calculate the correlation analysis. Kindly subscribe, comment, like, share, and don't forget to turn on your notification bell so that you don't miss any new video.